How are you all doing? So last episode we did some refactoring of the rendering API, or more specifically, we did a bit of refactoring in terms of how our draw calls for meshes are made. Yeah, and it worked out in the end. We had a stupid, weird, unknown bug in terms of NVIDIA Insight not really working as it was supposed to. So we had to swap to render docs for that. Yeah, so that's the basic thing. Let's see. Whoops. Well, that's some weird physics behavior here. Anyway, everything ended up working. As intended. And, hello, welcome. So yeah, I left off where where there was still some work to do, but everything got up and running. Our overall goal here is to, at least my goal is to build a level editor in engine. For that we need to refactor and clean up stuff. We also need some utility functions. So we need some utility functions for different rendering elements. So we need to refactor more parts of the rendering pipeline, or let's call it API. We also need some utility functions for rendering spheres. Or approximations of spheres. Since right now we have colliders that are actually spheres, but we have no way of showing them on the screen. Well, maybe we need a we need a data container slash level. Maybe we need some control flow. In terms of rendering the entire scene as dynamically versus statically. We also definitely need more UI work, plus a few bug fixes that since I found a few bugs. Yeah. And once we get set with this, I think let's see, maybe I can lower the font size a bit. We need, whoops. We need a object list that is clickable. Yeah. And we of course need some, well, object editor controls, as they're called in most UI designs. And we of course need more debugging utilities in terms of rendering. So overall, we need a lot of refactoring today, and I'm not sure I'll do it in any particular order. But this is the overall plan for the next few streams. Let's see. I just saved it on the desktop. This is an old plan that we don't need anymore. And we don't need this anymore, so I'll just move that. We have some old road maps. Let me just move them. Did I copy them? I copied them. I shouldn't copy them. Yeah. And last stream, I promised Karim to talk a bit about the material system and generalized architecture. Some of it will follow naturally from this episode since we're doing a bit of refactoring, and that will also be kind of like a review of the code. Let's see, I'm just gonna check some stream stuff here. There we go. Okay, so let's get started. I'll probably have to zoom in a bit. So let's see. Let's go through the whole system here. So whenever we create an application, which is done by the messaging system, we load some fonts. I actually tested out a different font since I don't like the current font. It's really, yeah, it's really not nice, but the viewers on previous streams wanted me to use this one. So I guess that's it until someone else decides that I am allowed to change the fonts. We use that font to initialize our UI system, which gets the screen width and height for our application. The renderer also gets initialized, and we built some resources. And we use that series of resources to preload some static information, which is obviously fine. The problem is that the application itself should maybe handle over all kind of like updating and control flow, and the application itself maybe shouldn't hold the actual data, but should have a storage of some kind where we maybe have a so-called level loaded or something, and the application could have responsibilities for maybe just loading that level and swapping levels. Hello, welcome. Let me see. I just needed to mess with some stream stuff. So yeah, we kind of want to change this way of doing things down the line. This is part of the map here where we would like a data container which simply handles oh, okay. Are you rendering 2D or 3D or? Oh yeah, you were doing 2D, I think, right? So this part will need to change. Let's do something like Yeah. Well, then a pixel is progress. So, yeah, we have this preload static. Sure thing, buddy. I can always tag you in the chat if I have questions for you or yeah. So we do some material preloading here. We simply do a vector of material buffers. Which we later on create a view to for our descriptor heap, which already got initialized during the setup of the render. This makes all the resources, pipelines, loading of textures, and so forth that, excuse me, needs to be set up before the application actually can run anything and render anything. So, but this then loads some additional information, creates further buffers. You could do this in the initialization step, um, but you could draw the line between something that is needed for uh, all kinds of levels and thereby basic rendering stuff. For instance, you need the debug layer for this application. We need a factory, a command queue, command list. We need a swap chain. We also want a buffer that can upload things from the dynamic upload heap to the GPU. We need pipelines of different sorts. And we of course need a viewport and a sysrect. These are all uh, renderer API essentials. These buffers here could be something that we consider to be somewhat not related to the actual pipeline, since it's like in Vulkan you have the uniforms. Um, I think they're called uniforms. At least they are in OpenGL, but um, that's simply just our data packets of different kinds. Right now, we know that most likely our application will need a so-called pass data um, instruction set for almost well, several of these shaders. So that means that let's see. I need to make sure I don't distract myself too much here. Just a second. Just a second. Okay, maybe I'm gonna do like this. No, that seems distracting as well. Excuse me, just a second. Maybe I can move this over here. All right. And then I need to set up my panels here. All right, there we go. All right. So you could argue that, excuse me, that okay. I just realized that we might want to swap this anyway. We've decided that we want a pass data buffer no matter what. So that's part of the initialization step. This needs to be moved. We create some debug visuals, which are basically just some different yeah, it's the coordinate lines. Maybe we don't need to do that in separate buffers. Maybe I want to do a, yeah, yeah, I think I want to refactor a lot of this stuff, uh, maybe today even, but let's remember to paste this. We left a warning for our future selves. But yeah, we set up some UI buffers, which have a size of some predefined value, global value, and we set up um, the buffer view. We could actually make a small call on our wrapper here, because we do not store a lot of data. We actually almost store nothing. In terms of our resources. And we could do a union where we get this information. Yeah, we will have, let's see, we will have vertex buffer views. It would also clean up what we need to store in our render API, and instead move some of it towards towards being stored on the objects themselves. And since the pointer probably will be cached anyway, won't they? Yeah, we could do that. We could even set that up at initialization time, and we could actually save ourselves these lines of code. Or we could do, we're not gonna do it on the fly anyway, so Hello. Welcome. That nickname kinda reminds me of Dr. Mann from Interstellar. Matt Damon's really um, dark-sided uh, what do you call it? Pioneer scientist. Yeah, you did? Did you get it working? Great stuff, man. No, but you'll probably get the hang of it pretty fast. All right, so yeah, I think we will. Whoops, I'm just messing around with stuff here. Oh, okay. I can show you how to work with getLine if you want to, though. So yeah, I think. Huh, that sounds peculiar. So yeah, maybe we should move this. I think uh, we will do that. Index buffer views would also be nice to grab. And then we have constant buffer views. Oh, you don't use the standard library one? Or is it the one that you tried but which didn't work? Let's do this all caps because it's an all caps state. Oh, okay. And this, of course, shouldn't be plural. Anyway, we would like that because we create vertex buffers, we create uh, index buffers, constant buffers. This doesn't need a view, but we actually do create SRVs as well. That's a bit more tricky though. Most of this is though, although yeah, maybe we want simply a union of sorts. Maybe an SR view. Yeah, well, at least you're on the right track, it seems. Well, it doesn't really matter that much where we store the information, but I do think that we might want to, yeah, because right now we want to, or rather, I'm not sure that we want to, but right now we store all this kind of information on the render API. Yeah, that's exactly what you do with the standard library. So seems like a good idea. Anyway, we these are fine to have stored on uh, the object. We could, well, this is also just a pointer basically. So we store some pointers here. That's not a lot of data. And as far as I remember, com pointers, well, they are simply just pointers to other pointers. So, and the information kind of like gets stored in the internal API object instead, which we point to. It gets created in the graphics, excuse me, sorry, in the graphics pipeline and on the GPU. So this is not very data intensive. We of course need a viewport and a sysrect, and we need some descriptor heaps. One for our depth stencil view and one for our, I don't like this name because it's for constant buffers, shader resource views, and unordered access views all in one. It's the way DirectX does it. And then we have a depth stencil buffer, a pass data buffer. Again, you could separate in terms of what is actually needed for the API and what is more draw call related. You might even have pipelines that do not use the pass data buffer. So you could argue that it's not basically part on um, uh, yeah, you could change that. Mm. Let's make uh, a section here, generalized API setup, draw call specifics. Usually, well, don't worry, man. Code not working is part of the whole process. Then you need to figure out why it doesn't work. Um, I don't know why you would need, well, I don't know how your code is structured, but yeah, in terms of efficiency and data transformation, I would probably separate the two, but it's probably fine. If you can, if you run into problems, you can always separate the stuff. Well, in general, you want data processing to be separated from uh, different parts of the logic. So that is an argument that maybe your model should only be a data container, only hold the data, and then you would have generalized functions written in a procedural way that process the information and transform it. So that would mean that yeah, or a list of models or something like that that supports several iterations. That makes the compiler compile code that is a bit more optimized, and also you can do threading in the future when you kind of like separate it like that. But um, for prototyping or getting things up and running, it's of course fine. But and I don't know your code, so it might be fine. It depends on how many models or objects or whatever you plan on handling. Yeah, so I couldn't say that it's obviously an optimization uh, or not, but in general, I think that I wouldn't. Uh, Yeah, but my concern is that you put a lot of different logic on the model class that needs to operate on different kinds of data and have different kinds of output, and that is usually not um, efficient in terms of performance. Look into the whole thing about data-oriented design uh, for performance. Um, I read was it this one? I don't know if it's this one. There was a nice article somewhere about it, how to structure it even with use of classes. Yeah, it's because you end up having cache misses. So when data is stored in a non-continuous manner and you do um, separate data operations on different allocations of data, you end up doing a lot of cache misses, and um, that really, really, really slows down performance. It's by a large factor. I've seen factors of 20 to 100 times. So that's the problem with object-oriented programming, that you need to take into consideration. You shouldn't accumulate a lot of different logic on the same class, because it will eventually um, not be easy for the CPU to actually process high amounts of data in that way. In general terms, because it all depends on what's the actual problem. That's why if you watch my series, my physics system is not class-based. I don't have any any classes really handling the physics system because it needs to do a lot of computations over time, and therefore I only data process on structs or allocations of structs. Yeah, as you can see here, the physics are just function calls that usually take, right now we do not support a lot of objects, but it takes lists of objects and do calculations of all the objects and keep them in cache. You can of course do code optimizations to improve the caching of the whole thing even more, but uh, still retrieving from a higher level of cache is faster than actually having to retrieve something from the memory itself. So yeah, there are design decisions that is relevant to consider when you build programs. Also, data-oriented design is way easier to multi-thread and do chunking on. Yeah, exactly. You're probably fine doing UIs, as my own UI layer is not that data intensive as well. I might do different parts of the UI in a more procedural manner where we do yeah, at least parts of it. I mean, the whole processing of the vertices and everything. Maybe let me explain a bit more in detail what I mean. Imagine um, you want to accumulate a a vertex buffer for all models. It's way more efficient to kind of like do all as much processing of step one together. That could be maybe parsing the file or whatever. Then translate as much of yeah, exactly. And you want to do that for probably several objects, as many objects as possible, and uh, then you translate uh, from step one into something else, and then you do processing again on step. Wait a minute, step one, on step two, then you translate step two, and then you process step three, and so forth. Um, so that is kind of what I do. Let's see, meshes. No, when did I do it here? I kind of like keep things in cache. Um, so if you see what I do here, I load all the resources into the same buffer set, meaning that I don't reset this program here. It's the OBJ reader is basically a data container, and it does have some logic on it. You could split that out in procedural programs instead, or rather methods instead, but um, resource views are just um, um, I can't recall. Are you using DirectX 11? Yeah, okay. Because in DirectX 12, you simply just map your resource views to wherever you want the data entry to start. So it doesn't matter if it's one texture or five textures in the same data container. You can simply map your views to different starting points of that data structure. I don't know if you can do it in DirectX 11. I don't think it's as flexible. But yeah, no, but yeah, I don't know your program and I don't know your generalized structure, so you might be fine, but just be mindful that you don't want mega classes that do a lot of different stuff. And if you have multiple objects with data that is not continuous in memory and you do data processing on multiple objects, you would end up in a situation where the CPU has to fetch the data from all over the memory, and it spends a lot of time pulling things into the cache and reloading the cache. And um, yeah, for instance, let me show you a simple example of what I mean, because it my current explanation might be really ambiguous. But imagine that you have a struct of some kind where you want to hold the position. We have a vector 3 of position, and yeah, every object in your every object in your program has this component, it has this information, um, and you have a generalized function that you would want to call that is called update position, where you take a vector of position uh, positions here, and you do some operation on them. You want to update all the positions. Maybe you want to move some objects and some objects not. Um, um, if you have a vector of these things, um, like that, and you allocate the data points, um, they will all be continuous in memory. And this means that if you call your update position on this vector of positions, the CPU will be really fast at doing operations on them, because it will know where to look in memory, and it will probably just load this whole vector into the cache if it's possible to fit it. At least it will decide on aligned chunks, as it's called, meaning that it fits a cache line, and it will put that into cache and process that. Then it will move on to the next part that fits a cache line and so forth. But imagine that you, instead of this, have something called object data. No. This is a CPU agnostic problem. This is generalized programming problems, since this will affect your performance once you get up to the scale of a game engine or a game simulation or even a 3D model viewer or something like that. It really matters once you get a lot of data points. So it doesn't matter how fast your CPU is. This will just mean that you can offset the problem until you get to a certain scale. But imagine that, because I'm not done, um, you have something called vector some data here, and you have a vector called some other data, I'm just going to do pseudocode, so it's not going to be precise here. And then another vector, some data, then some, maybe some bools, something, maybe some ints, something more, blah, blah, blah. You get the idea. And we simply change this to hold all of this data. And this will be object data. And this will be object data. Now the CPU will have so many cache misses because it doesn't know how to select from all of this data. The data is spread out in between each instance of this struct. And that means that processing of this data gets really, really slow. A struct is basically the same thing as a class. There's no real difference. In C++, it only matters that a struct is by definition public in terms of its member variables, and a class is sometimes private, sometimes public. But you can actually do structs with constructors, methods, and so forth. So there's no real difference. This means that if you well, 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 yeah. You were talking about dynamically loading objects and not knowing the model except at runtime. So I would be mindful of your design choices in terms of how to structure the code. Yeah, it's probably pretty fast. But things add up, and if you end up in a situation where your program is structured such a way that your CPU has cache misses, eventually your CPU can compensate for that design choice. So yeah, but of course it might not matter for your specific problem. It's just some generalized considerations in terms of programming design. Yeah, and group data by small chunks. I know my program doesn't really do that for now, but I at least know that is something that I need to work towards. And yeah, decouple logic a bit from your data storage. So, for instance, calling something like class 1 do update and class 2 do update and class 3 do update, blah, blah, blah. Is way slower than a vector of data points, data, and then calling a update data points, reference data points. This last one is way faster by a large magnitude. Yeah, this thing here means that every time the CPU wants to do this function on a class, it has to look up inside this class. It will have some it will have some data. And it has to look up that data, then process it, then take the next object, look up that data, process it. This way, the data just gets organized, ready for cache or fast processing, and then you do all your processing in the same method where everything is loaded into cache. So this means that classes are fine for a simple yeah, cache misses are just what does the CPU have loaded into the cache right now? What is it doing work on? Uh, and and what is outside of the cache and not really being worked on recently. Um, a cache is simply just a really fast access memory storage of a limited size. It's usually also aligned, as they call it, in terms of how the memory layout is. Yeah, modern CPUs have different levels of cache anyway, so and the higher the level, the slower it is. So yeah, that 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 is the explanation why I get a bit anxious when people say, "Well, my class has a lot of behavior and probably a lot of data," because that means that they might end up in a situation where the CPU will get slower in terms of doing the class logic than otherwise would be the case if you made other design choices. And I use classes all the time. I mean, um, you could do that. It's fine. It depends on if it's on a per frame basis and you have several thousand frames. Well, then it does get called fairly regularly. If you only have one object in rotation, well, maybe it's fine. It depends on how much data processing you do in the function. Um, so yeah, I can't really say that it's a bad idea. I can't say it's a good idea. It just needs to be, um, yeah, a generalized design consideration when yeah, maybe when your program is done, you can look into how to optimize it. I generally try to plan out as much as possible in terms of design choices so that I can get as much what do you call it, structure done in the program so that I know either I can optimize the actual data processing of the application later on, or yeah, I don't have to rewrite a lot of logic to be able to do those kinds of optimizations. But yeah, anyway, yeah. I know. And I'm sorry, it wasn't to do a lot of ranting. I have no knowledge of your project, and you will probably be fine. Uh, I'm just kind of weary of the whole object-oriented programming style of doing things since they have real performance implications if not managed properly. But yeah, as I've mentioned, I do a lot of classes anyway, and most of this system is built around different classes, so it's not that I don't use them. It's just I try to manage how much data processing goes on in the objects. Anyway, I should probably get back to it. I was uh, getting off on a tangent about data processing and CPU cache misses. But it was kind of, hello. Anyway, yeah, it seems like it, but okay. So I was considering moving all of these parts here into the resources themselves. The resource even gets the device. We could do something like, oh, this is a specific one for textures, I think. We do different calls for textures. Yeah, we do. I don't know, probably a while. But sounds good. Feel free to hang out. Okay, sure thing. Feel free to mute me though. I'm gonna talk for future reference in terms of if anyone watches this in the future. Um, let's see. So we want to change the way this works. I do think a union gets stored according to whatever is the biggest. Okay, and what do we actually store? Well, the vertex buffer views and index buffer views seem like something that is different. We don't. Let's see. So we actually don't have to create them on the GPU. The CPU just needs to provide a pointer to a memory location. It seems. unless you want to access them through a descriptor heap. Yeah, the views here. This means that we could end up storing some information. This is for committing to the descriptor heap. Yeah, maybe we don't want that to be part of our object. We could collapse all this into something like pre-create the descriptor heap, then when we do SRVs, because we right now want to well, and we would know that the sub resources and MIP levels this function does it actually store the, let's see, resource description, MIP count. Okay, so it really kind of like does that already, right? Okay, we only need these components here. I guess you could do it after, simply do a create a resource view. Yeah, I guess we could collapse that. Yeah, let's just do it. Let's just do it. Enough contemplating. We will do it. It's not data intensive anyway. So inside our resource here, we want something like a union, let's see, of different things. We want either a let's see, I haven't worked a lot with unions in C++, so syntax, let's see, blah blah blah, union name, of course. And we will do either a vertex buffer view, there we go. Oh, this is actually a definition, I think, like a class. Yeah, it is a definition. So we do like this, buffer view, resource view, and we of course predefine that up here. And we probably want it to be public and we define it down here. Let's do a vertex buffer view, a D3D12 index buffer view, a D3D12 constant buffer view. Oh, wait a minute. Hey. Yeah, okay. Now I remember. So I'm unsure whether we actually have a D3D12 constant buffer view description structure. And a vertex buffer view. Let's look that up. It's basically the same. So I don't know why they named them, excuse me, in a different way, but a D3D12 constant buffer view. Whoops. Constant buffer view description structure, which basically holds the same. This. They could kind of like have cut off that, but D3D12 vertex buffer view. Let's see, as you can see here. I mean, what's the real difference? Nothing really. Anyway, let's see, SRV view description, shader the resource view description structure, and this holds a bit more information, but this is also a union, which holds a different kind of structure. Would we like to create shader resource views that way as well? We could do that. Let's just do it. Resources will then hold their resource information and a view. And the resource information is really, not really anything. Yeah, this would mean that we can move all these view stuff thingies outside of our renderer API. Yeah, let's do that. They're stored anyway. So yeah, maybe we should store them somewhere where they are close to whatever other variables we might need to access in terms of accessing resources. Yeah, we will do all in one. D3D12 constant buffer view description, CBV, and then a SRV. What did we shader resource view? It's simply verbosely, or rather typed out, shader resource view description, SRV. Do we want to be able to store a depth stencil view? Because we actually do create hello and welcome to the channel. Why I need to edit levels in order to build levels for the game. But that's maybe not what you meant, or the problem is with these two, or rather maybe three parts. Mm, maybe we want separate unions here, but I don't like allocating a lot of extra memory. Okay, we will do it still this way. Maybe it's not. Let's see. Definitions. Actually, I think it's declarations. And we will do a resource view. Maybe. Am I not allowed to? A union is a data allocation where only one of these members get allocated. So this means that I don't have to hold all of these types of data. I only have to hold one of them, and it only needs to allocate the maximum possible size. Let's see. Union. Incomplete type. Yes, because it saves you memory. You don't want to use unnecessary memory in a game application. Let's see. Maybe. Yeah, that won't work. It's because of the forward declaration not really working. Maybe this should be private. Maybe. Yeah. Because no problem. It's a good question. So Good you asked it. Let's see. So now we are allowed to store uh, uh, our view information on the actual resource, which means that our renderer API doesn't need to keep track of it, and it is also stored close to the other resource information, which means that if we ever were to access something in terms of the methodology of the specific resource or the data of it, the CPU wouldn't have to look far. So we have to move, for instance, this part. So whenever we call initialize, we could simply do something like a enum where we pass in the type of buffer and we create a view for it. We could also do a overloaded function where we allow to create a view at the same time, so that we could initialize a buffer without creating a view. Perhaps that is a bit more interesting. Right now we can only hold one view with our object. For our current use case, that makes the most sense, but actually DirectX12 allows you such a degree of control over how to interpret your resources that you can actually create multiple views for the same resource and simply map different parts of the resource to different kinds of buffers or resources for use on the GPU. So in theory, and in practice, of course, you could hold different descriptors and views if you ever wanted to do optimizations in terms of resource management. Perhaps you wanted something like a constant buffer or maybe even a shader resource view for a compute shader, as they're called, which is the asynchronous compute shader that is used for AI processing on the GPU, for instance, where you upload a 2D or 3D array as a texture, a shader resource view, and then you do compute shading on it, and then you maybe want to read this, the output as a vertex buffer afterwards. Maybe you. Hello, welcome back. Oh yeah, I didn't realize that we got this that far. That's great, man. Welcome to every new subscriber. Happy to have you here on the channel. Hopefully some of this is helpful, inspirational, or just perhaps a bit entertaining. If you ever have any questions or want to interact, feel free to do that. I'll take the time to interact throughout the stream. Anyway, I was blabbering a bit. What I was talking about was a way to handle whether we actually depth stencil buffer. Okay, I think we use the same call for SRVs, but slash textures. We could do something that I know works. We will do a forward declaration. I don't know why it didn't really work with the union stuff. Maybe I'm missing something. I haven't worked a lot with unions. But we could do a enum class here, resource type, where we set it to a default buffer, which will simply just be a buffer. It could be any kind of buffer, we don't care. Then it could be a vertex buffer. Then it could be an index buffer, a constant buffer, a shader resource. Is that and a depth stencil buffer. Yeah, let's do the buffers first and then the shader resource. Okay, so we do this enum class here. Let's just copy this and collapse it. We do forward declarations and then yeah, since we will need to call it outside the class and specify it, we need to do it public. So we simply create overloaded init functions where we pass in a resource type. And we default it to our default type here. This we will know that this method allows us to initialize a view as well. And we could of course do the same thing for this one. We will define those right away. And we will, of course, just call the function here with the width, height, and then did we miss something? Oh, it's because we defaulted. Well, we aren't allowed to default it because then we have no way of deciding which one to use when we only have a limited amount of arguments. Thank you for pointing that out. Visual assist. Let's do a init here where we pass in the device, number of bytes, the heap type, the initial state. We could also do a constructor. Well, we probably don't need it. We seldomly use these custom constructors, at least in the current program. Anyway, let's copy this as our working model. We do a switch. If it's we could grab the information. Okay. Well, we need to pass in stride and bytes would be needed for a vertex buffer, a index buffer, I suspect. Yeah. Oh, that's the format. Okay. Maybe this is the wrong way of doing things. Maybe this is the wrong way of doing things. Yeah. Yeah. Okay. I've changed my mind. It's not gonna be like this. Whoops. Let's just delete these functions then. Because we need separate methodology to do the view creation. Let's see, size. Is that just a representation of the byte size? Yeah, it is. Although we could do what we just did. We could do what we just did. Okay, maybe we do this after all, because we then just need a this should of course be const. Yeah. It's pretty crazy. It's so nice that people drop by the stream. Yeah, thank you. I'll try. Uh, I'll try to do the tutorial stream tomorrow. I'll probably do offline recording as well during the stream, so I can upload the videos fairly efficiently. I need to coordinate with my girlfriend what time it'll be, but it'll probably be during the afternoon. I try to. All right. Because the way that we create these views are we access the resource itself. Well, the resource never really gets initialized in this part of the program. Let's see the out resource. Let's see out resource. Where do we reference it? Do we initialize it? It's actually just a data container. It's an empty object that we initialize in a different way. That's an argument for doing simply yeah, maybe we need to decouple this. Maybe it's just not as elegant as I'd hope. Resource type. Yeah, we delete that one. Okay. I've decided that we will do a create resource view, and we will pass in a resource type, and we will do and this also needs to be const uh, uh, slice size. Is that nonsensical? Chunk size. I think I like that kind of wording better because I want to signal that most resources do require some kind of information in terms of how big is the buffer total. We already have that on our resource, but also how big is each sub-object of the resource. So I think get memory. Oh well, it's because I'm not done editing. And this will also a vertex buffer view. And let's see, index buffer view. Yeah, this is actually duplicate code also. Yeah, okay. So we will do some default arguments here where the chunk size is 0 in case we are trying to create a view to a shader resource view. Let's see the depth stencil. What does that need to? Of course, we need to do that. Let me see. Okay. The depth stencil stuff here. It really doesn't take any dynamic arguments. They are kind of like hard-coded in terms of pipeline setup anyway. So, well, that means that for now we only take one additional argument other than the type, and we do a switch on the type. And let's do a well, we don't need the default because we won't be creating anything like that. And then break. And then we will move our code for an index buffer inside, or rather vertex buffer inside. So let's do that. Our member variable resource view. Whoops. And we will do a vertex buffer location, and we will simply call get GPU virtual address here. Let's see. It will be chunk size, and then R. And we will do our size here, because we already stored how much data is going into that. So, okay, let's test this out with our vertex buffer here. We would simply do something like this: create resource view, resource type. Oh, D12 resource type, vertex buffer, and we would like a chunk size that is this big. Let's try deleting this then, or rather commenting it out. And let's try finding this. If I highlight it like this, I think we will use it inside our rendering step here. Yeah. And what was the name instead? Let's just set a breakpoint so I can easily find it. The vertex buffer UI. Well, we need a method, of course, to Be able to get the reference to our information. We could do something that will look a bit funny, but will allow us to create only one method. I don't know if it's janky. This should be called get size actually. We will refactor wherever we need to. We could do something like this. Where we simply return the address of our member variable here. And then wherever we want to use it, we simply cast it to whatever type we want. We could do this. Let's see if we have any. Yeah, we have some problems in terms of somewhere we have an error. Yeah, there's a lot of warnings here. I failed. Warning. Is it inside here? We have any errors? Nope, it's not there. Is it inside here? Error. Linear buffer. Let's see, memory managers, linear buffer. There we go, get size. Okay. Yeah, we of course need to change that. So the vertex buffer UI. Get view, and then we simply cast that to a vertex buffer view. Pointer. Let's try that. We do not get any errors, and everything works. So that's great. Now we don't need to store the data on the renderer anymore for that. Let's simply get some error highlighting here. That vertex buffer view is gone. That vertex buffer view is gone. The vertex buffer view. Let's see. Vertex buffer view. Vertex buffer view. We remove that. And we will, of course, have to clean up this. We will copy some of this code here. since we will basically be doing the same thing. So there we go. We should also rename this. Yeah, I think while we're at it, we will rename it. Vertex buffer, polygon. Yeah, let's do the, yeah, we do kind of like whatever it is and then the type lastly. So we do polygon, vertex buffer. And we of course delete this. We don't need it anymore. Let's fix up submit objects. I think actually this will be deprecated, not used anymore. Let's see, hopefully everything compiles. Let's move this down in our graveyard. Anyway, submit game objects. Let's see. That's our new method. Uh, sub submission of dynamic draw calls for polygon game objects. There we go. This one needs to be reset, or rather deprecated. Yeah, we're really refactoring right now. We will move these up to a deprecated area, or rather, maybe not even deprecated, deleted area. Okay. Oh, oh, this is something related to, well, we need to clean up that later on. It doesn't contain any errors, it does it anymore, but we assigned buffers here, polygon vertex buffer. Let's see, submit game object data, that one was clean. Yeah, these are related to the debugging stuff. This is for the polygons, which also, this solves also the hassle of um, trying to figure out what is that object. It's kind of like easier to read, and as well as I think it's more efficient, quote unquote. There we. Oh wait, we can't compile because we're not done yet. All right, let's see. Is it inside this one? Nope. It's. I think it's inside these two functions here. Yeah, where we actually create the buffers. Okay, let's see. Let's just copy the code. And the slice line is the size of this struct here. Let's see, extra vertices plus, yeah. It does get cleaner, and we don't need to do as many multiplications anymore, so that's great. The box thingy here. Of course, we need to do the same thing here. Let's do that, the line buffer. There we go. Delete that. And we of course need to clean this. So this is the line, debug line, pipeline, coordinate system. Wait a minute, it's part of this vertex line buffer. Okay, we will do that lastly. But now I have debug boxes. And we of course want to cast that as that. And we do the point stuff, point, billboard buffer. I actually want to rename that because line vertex buffer. This is system related. Pass data buffer, index buffers, buffer allocators are also system related. Whoops. Therefore, we move that. Let's move this. Let's move this. Okay, and let's rename it. Line box UI vertex buffer. There we go. All right. Hopefully we will be able to figure out actually think we will deprecate that as well. And this is point buffer. So this is it's UI buffers. Buffers. Polygon buffers. Let's just line buffers. Okay. Let's see how many red squiggly lines we're at. So vertex buffer UI. UI vertex buffer. There we go. Let's see. Box, pass data, blah, blah, blah. Vertex buffer box. UI, vertex. Okay. Then our first error is this is bounding volume buffers. So it used to be box buffer. For the bounding volumes. Maybe we want to name it like this because it makes more sense. Find the lines. This is for the. There we go. Okay. Then we will, of course, need to update the. Yeah, we will do a lot of renaming here. Let's see. Okay, that is not implemented right now. I think we will do a rework of this stuff as well, because yeah, since debugging information is not something that we want to use in a release build anyway, I think we will stop doing all of these separate method stuff thingies and instead do something else like this on a per frame basis upload, even of the debugging information. This is kind of janky, even though it probably adds a bit of more CPU work to the actual rendering part of the program. I do think that the control flow of the API gets better, and yeah, you could always work with static and dynamic object handling anyway. Yeah, but yeah. UI vertex buffer, there we go. And I think we've expanded most problem areas here. And we changed the name of these things without running into trouble. Yeah, right now this is a separate buffer. Let's see, line vertex buffer, get new. There we go. Bounding volume line, yeah. Bounding volume draw. And then we have the billboard point stuff. What did I call that one? Point. Maybe we want now polygon. Maybe. Okay, maybe we want to flip this so that we have some kind of, well, points are always supposed to be drawn as billboards, I think. Yeah. Let's just rename that. This is specifically for the UI. It doesn't have a particular drawing type. This is particularly for bounding volumes, and this is for other line segments. This is for polygons. Yeah, I think we do that instead because the billboard thing just is confusing. Anyway, get description, or rather view. Well, I certainly did the exact same thing that the DirectX API people did, and that is confuse a view with a description. Actually, I shouldn't say confuse, it's because they are the same thing. The terminology is used interchangeably, a description and a view. Line vertex buffer, let's see. And we want to call the method where we create the view for it. There we go. And it's like that. And we can delete this. Now that looks way better. Let's see that everything works as intended. It doesn't. Well, it's because we don't want that anymore. Everything still draws. We're happy. Also, when we move the bounding volumes about, we want to update them as well. So yeah, that's another reason why we would do dynamic draw calls for our debugging information. Okay, now that we've expanded everything, let's see. Then we have the index buffer, which I'm pretty sure is used for polygons. So we move that. And we simply delete that one and start testing. So preload static items, blah, blah, blah. And then we want to be able to create a index buffer where we ask for a index buffer, and we don't need anything else. We simply move this code inside our thingy here. And index buffer view, buffer location, like that. And then we copy this and set format. And then we copy this and set the size in bytes to this size here. And that's basically it. Pretty awesome. Let's update this to get the view. And we want a index buffer view pointer. There we go. And this should work. And it works. Great stuff. Okay. I think cleaning up one item by one is constant in data buffers. Oh, we need to do a lot of cleaning here. And we need to do renaming of this box. Bounding volume, line, index buffer. All right, we need to well, thank you for your everlasting support. Let's see, create resource view, and we simply copy this part and tell it that we want an index buffer. Okay, get view. And let's see, do we, yeah, we have one, yeah, we can copy. There we go. And this compiles. Great stuff. Everything is getting cleaner. Is that the only index buffer we did other than, yeah, probably. It's the only, well, points do not need indices. Lines don't need indices since they only have 2 points. Well, I guess that was it. Then we need to check for other views. Do we not have any other views? Well, they're not stored then. Well, that's an argument against doing well, okay, let me do a short break here. Be right back. All right. I think, yeah, everything should be working again. Okay. So where was I? Well, we could change these descriptor creations. Even though it doesn't matter too much. We could do it. Uh, Does this need any specific information to be created? Well, it's really not using anything. All it would do would be cleaning up our initialization stuff here a bit. Well, okay, I guess we do it. Create resource view and then a D12 resource type of depth stencil buffer, and we simply move this where we do a depth stencil buffer. We don't even need to store any information here, which makes it different than the other things. Maybe you don't even want to store it. Maybe that's the problem. Yeah, maybe that's because maybe we don't want to actually create buffers that way. Constant buffers will be handled that way, but yeah, since we don't store the information, I only think that we pass along the information and then it gets stored on the GPU when we pass along these descriptions, except of course the constant buffer view. Yeah, maybe we just want maybe we just want some basic functionality. I mean, this should probably be disabled. Yeah, I mean, this obviously maps, and this also obviously maps, but this is just a description. Well, okay. Maybe we don't want to do that for a div stencil. It probably doesn't make sense, and the struct itself is so small. Therefore, well, we can still create a resource with that kind of type. So maybe we want to deprecate it, or rather remove that. Since this needs to access the buffer itself, I guess they're fine creating like that. Let's see. Yeah, so this would mean that we do something like descriptor heap setup for both materials and textures. Let's go. Let's do this scoped. And then we would like let's remove this. And instead do a shader resource. And for now, this will be standardized. Let's see. It doesn't point to the actual buffer itself or what? It doesn't care, it seems. Well, this one does it for it, so anyway. Okay. And we get the underlying pointer and get the description and then the format of that description. And we specify the view dimension. We specify the component mapping. And right now we only support texture 2D. Since we initialize our information the same way. Yeah, we could do oh, wait a minute, we need to copy that. Maybe we want something different for shader resources actually. Let's just type this out because I'll need it anyway. So we have the and then we have the plain slash equal to 0, yeah. Okay. I'm thinking that this will not be the call for that. I think we will do some inlining here. Oh, wait a minute. Maybe the compiler will inline it for us. This should probably be done, not on a per frame basis, but if we do resource streaming in the future, I think that we need some kind of dynamic system for it, but yeah. Yeah, we could do could do okay, maybe I'm fine doing this. We could always migrate it out into a separate function later on, but the thing is that I would probably want to set different parameters for the SRV descriptor, and therefore I would probably like a function separately that does take a few arguments and then passes back the SRV. Also, since we do not store it, well, we could actually eliminate this data storage by well, okay, we could change this down the line. We will do it like this, even though it's maybe not optimal. Okay. So now we should be able to just call textures, create resource view, D12 resource type, and shader resource. And it should be able to pass that information, or rather create the relevant information. And then we should be able to delete this and be able to specify what is the resource view pointer. Get, wait a minute, the zero index get view, and delete this. And of course, cast it to a resource view here. There we go. Let's see, does that work? Well, this should be our texture 0, so everything seems to be working, and I'm not getting any problems in terms of output. Nope. Great stuff. Finally, I reached 69. Congratulations to everyone on the channel. We've done great work in reaching the magical number of 69 subscribers. I wondered whether we would hit that today. That's really awesome. Now, what will be our next goal in terms of funny numbers? Do we even have anything to strive for? Okay, let's see. So if I simply remove that and simply copy this. Yeah, that would be a nice number. Even 500 subs and enough viewing hours would probably maybe allow me to provide access to the source code for a small fee or something. So that would be really nice. But anyway, I'm happy that we reached this epic number of subscribers. Welcome to everyone new on the channel. If you have any feedback, anything you want me to do differently, let me know. I can only change it if you help me out in that sense. Yeah, that's a linker error. So you need to make sure that the linker can find your methods, and when you're importing and exporting things, that you have the correct um, uh, preprocessor definitions. Let me show you. So it's not here. In the preprocessor, you need to define these values if you're importing or exporting. So for instance, here, this checks if we need to build the coding. Let me show you just a sec. I'm in a problem here where I just need to, oops. Just a second. Let me compile. Yeah, it's for a game where, yeah, we're doing different stuff. So that's what I'm working on. Right now we're doing some code cleanup in terms of the rendering pipeline. But Ryan, I will be doing a beginner's tutorial tomorrow, where I will walk through everything you need to be kind of like set up with um, DirectX12. At least, yeah. I'm not sure that I will do a whole setup in terms of doing a game engine, since the architecture you would need to make yourself. But I will show the process of drawing something to the screen from A to C. Maybe I will even do a 3D version, since most tutorials only do the 2D triangle anyway. And I will provide the source code for that on GitHub. Um, Protogen, I hope that answered your question. If not, feel free to ask again. Let's see. And let me see. Can I do a planned stream advertisement on the YouTube panel? I don't know. Well, we'll see. Maybe I can't do it during live streaming anyway. All right, so let's group these together. Number 3 here. Ah, okay, great, man. I'm happy that you got it working. The linker is a bit tricky, so um, don't worry too much. Usually, if somewhere it can find the function declaration or the function definition. Usually, it's the definition. Um, And yeah, when you're linking two projects together, it's even worse. I even think that this one is set up as a, let's see, reference. Yeah, I even referenced the project here, so it needs to build the engine before it builds the game. All right, and let's see, we do it for number 3 here. We can move on to number 4. Whoops, what am I doing? Brain fart. There we go. And then we will have number 5. And we're getting close to done with this part of the cleanup here. Then we will start deleting functions. Well, I don't know. That one showed. Yeah, exactly. Okay. Let's change this. Then we will do number 6 and 7, and then we're done. This looks somewhat better. In terms of performance, it probably won't matter. but it's been something that I wanted to do anyway, so and since we're cleaning up the renderer system anyway, we might as well do some small improvements that were planned all along. Okay, and our numbers seem to match, so we have 3 7s here. We have 3 6s, 3 4s, 3 3s, 2 3s, or 3 2s, or and 1, and if everything compiles and runs exactly as it's supposed to, well, this is intended behavior, so now that's more clean at least. From file into resources. I've mentioned that you could branch this off into a different part of the renderer that will be done in the future because we would like to be able to stream different resources during runtime. So yeah, we need a method to load textures and append them to buffers and so forth. So, or rather, maybe not buffers, arrays, or well. Well, I guess it's just what it is. Um, I I did only start about maybe 3.5 months ago or something like that. So, and I don't do any. I don't do any editing, and live streams are probably something that have a bit less traction. So, it's pretty fine with me. At least I have now approximately 100 videos on how to do uh, game development completely from scratch in DirectX 12, so that's pretty good anyway. And I'm doing this anyway, um, so I might as well see if someone else can have find help or inspiration in some of the videos or the work that I've done so far. So as long as a few people have been happy with my videos, they thank you very much. All right, so now we've done a bit of refactoring on the resources and their views. We decided not to do the depth stencil views. Now I think we don't need to clean up anything in the init function, as for now at least. We do our pipeline stuff, that looks fine. Maybe we should translate these bit sets as into a enum because, well, they're kind of hard to read. I know that it's a bit mask in terms of which shaders to compute, but well, that's like a feature or thing that is minor and doesn't have any great effect on anything. Okay, so that's a good way of doing things. I've deleted a lot of stuff and redone things over and over. It gets you a firmer grasp on each of the components. Okay, I might want a coffee break. No, feel fine chatting. It's nice. I'm reaching a point where I'll have a coffee break, probably on stream. We haven't created an overlay for that. Uh, in terms of the stream, which I might do. Anyway, let me just refocus and do a bit of planning in terms of what to do next here on the stream. So yeah, we reworked the buffer setup. We rearranged what is necessary for the system, the render API to run. We cleaned that up a bit. We have some system variables also. Uh, that is way more clean. I think, are we actually using these material buffers anymore? I'm unsure that we do. Well, we do. The material buffers and the texture buffers, of course. Uh, uh, these are also draw call specifics, and right now they are used for the system. And now we're getting into, these are also our draw calls. We could name those in terms of yeah. Let's delete the old buffer stuff here. We will keep this for the test variables. Actually, I think I will delete this, or maybe just move it into a graveyard area. Let's do a pragma return graveyard. Pragma and return, and let's do like this. There we go. Okay. We will redo some of this. We will redo all these methods here. Yeah. Yeah, I'll have to refactor the render API here. Okay. So the plan is to do more refactoring. Let me see. Let's do a let's do a maybe and oh wait a minute, yeah. Can't remember the resolution. Okay, 1280 times 920 720, and we do a black background. Let's do something like this. Okay, we can just move that. Set our background color. And would we need some advertisement here? Let's see. That's an old one. Let's edit this. Copy this and paste it here. It's not center, I know, but let's do it like this. And I will save it. And use it as an overlay for the stream. Let's see. Overlay coffee break. And let me see. Yeah, right now we have a black screen. We copy this. There we go. And we could add a image coffee overlay. And let's find our overlay here. And transform that fit to screen. And we could, let's see, does it change? No, it doesn't. So let's see. Whoops. Now I'm messing around with this. Let's try, whoops, that's the OBS chat panel. Let's keep the aspect ratio a bit. We could move. I know this is not relevant to very many of you. Feel free to skip ahead if you're watching this in the future. And let's just maybe, no, this is fine, at least for now. I'll stay on the channel with the mic on, and I'll access the chat on my phone if I can do that. Does the app even support that? I'm unsure. Maybe not. Maybe not. Well, I'll have to check the chat when I get up. Otherwise, maybe I can do... No, maybe let me check this. Maybe I can just watch the stream on my phone. Well, let me turn off the sound. Okay, I can only see the YouTube chat right now, but it is what it is. I forgot to enable the chat also on the stream. Maybe during coffee breaks it needs to be bigger. Just gonna boil some water and then set up the chat overlay as well. And we copy the chat here. During coffee breaks we need a large chat. There we go. Alright, so far we're making small but steady progress in terms of refactoring and cleaning up the code. The next step will be to implement some dynamic line buffers for our debug information for both bounding volumes and different kinds of line drawing mechanisms. Yeah, I would like to upload the bounding volumes each frame, even though they sort of like will be additional calls to the render API and several CPU cycles to copy the data over each frame. But since we're going to do a level editor where every object will have to be dynamic, and since high performance during level editing will not be a priority, we will we will do like that. It will also mean that we, from the application itself, should be able to switch debug information on and off, which is also a great improvement. Right now, we either have to render it or not. So it gives us a more flexible system at the cost of potentially activating these functions and reducing frame rates. But I think that it might also increase the frame rate when we disable it. So yeah. Okay. My coffee will soon be brewing, and then we can do more work here. But feel free to interact. I'll most likely see your messages soon enough. Oh, we got our 70th subscriber on YouTube. Welcome to the channel, buddy. I'm happy to see the number increasing, but also I feel a bit sad about the number changing from 69, since it was a very memey number. Well, if I had to choose, I'd still choose the number 70. We had our fun. All right. All right, now the coffee is brewing and we can get onwards. Let's swap back to streaming mode. Everything looks fine. Oh, okay. So the general idea is that we want something like this for our debug information. Usually our debug information consists of some kind of line drawing mechanism. For instance, our bounding volumes consist of vertices and indices. And we wouldn't mind creating draw calls each frame copying the specific data. The problem is that we would have to compute the data. Live, sort of. Let's see. So for lights, we do this kind of computation where we simply, well, mm, well, the problem is that in comparison, we will work with a dynamic vertex buffer, since we won't know all of our vertices beforehand. And that makes the debugging computations rather slow. But as I've mentioned, debugging is not made for performance critical parts of the engine. It's just some support functions that make us able to work. Sometimes we might even not want to show our bounding volumes, for example, which will probably be the most CPU intensive to calculate for each frame. We could also do frustum clipping in terms of not rendering bounding volumes that are outside our camera. Yeah, we could do several optimization steps in terms of handling a very large computation burden in terms of doing doing these kind of computations and copy calls for each frame. Okay. This is for the materials preloading. We preload the models here into our polygon vertex buffers, and we upload them. And we flush our data. And we did some deprecated code here. Yeah, let's move that. But reserve the okay, so how are we going to structure this part of the code? We obviously need a vertex and index buffer. I think we will rename this, since the line buffer here I think is used for also casting rays, right? This is the casting rays bounding volume. Or do I? Let's look into the old method. Add ray. Box. Add debug visual array. Yeah. So we actually do the same here for the array. Hmm. And this is overflow protected. Yeah. Okay, I think we need to simply reorganize all of this. So our static data is kind of like pre-built in a way that allow us to make simply register draw calls to known meshes that is already uploaded to our vertex buffer. We would of course need to change this whenever we do some streaming. Well, now the streaming would just have to append the or even expand probably the existing vertex buffer. Yeah, you would have to implement some kind of buffer handling system if uh, the resources kind of get overcommitted. Then you would have to handle that. Okay, so the general idea is that we at initialization time probably uh, since these are preload static information preload materials and static draw calls. Okay. And let's move this into texture loading. So we can collapse it, texture, and texture, loading, end. Okay, this kind of looks like a function for IntelliSense. Therefore, it will do like that. Okay. We create some UI buffers. Maybe we want some buffer here that yeah, maybe we want system buffer creation. But well, we would like a separate call actually, and since we're not we want the option of not creating any buffer space for a non-debug version of the system. So I actually think we want a separate call. We will be deleting a lot of these different things soon enough. So let's move this downwards. And let's structure it so that our initialization time or startup time methods are first. in line in terms of the definition or the declarations. Um, Setup, maybe just init, debugging, buffers. Maybe we would like to call it create debugging buffers. And then we would like something like submit debug data. Yeah. And we would basically get rid of a lot of different stuff. Maybe add is a bad way of doing things because we reset it every frame. Maybe submit is better, actually. I actually think so. And inside our application here, we need to fix that. Okay, so every kind of quote-unquote upload to the render API is is a submission. And we could segment this into a scope. Maybe we want some billboards as well. Maybe we just want to handle everything at once. Since they're all grouped together, maybe we want a point list, a primitive list, yeah. Yeah, let's close these functions for now because we're kind of done with them. We're gonna kind of like squash all this functionality together into one big runtime uh, thing. We will migrate everything out. This will be uh, removed in the future after migration. We will simply create something where we new debug system for lines plus line well, we could do basic wireframes for our wow. Well, that would be a future optimization to do a separate wireframe pipeline for these kind of primitives. Then you, well, I guess you would end up with weird lines, and we have a bit more control over the primitives. Okay, and we will create some maybe we want to name it debug. Debug poly index buffer. Yeah, we will create these two resources in our newly created method here. And we do get the same ordering as before. Let me just snap these resources here. Okay. Maybe we want some overall debug visual information. I mean, right now the debug item, which we will actually rename to a render debug draw call, and do the exact same thing because it makes more sense this way. Let's just predefine it and remove the old render item here. Yeah, because we will have no way of knowing whether we get past a box, a sphere, a point, or a line. Those are the debugging primitives that we will support, and we will simply use one big buffer for everything. And our draw call here will be able to segment the specified index buffer. Totally fine. Yeah, so I think we need to create some sort of primitive type system. Let's move this down here. This is for the buffer information. Well, we will actually be using the exact same thing, so we will be able to deprecate this because it's redundant when we change to the new system. Okay, so we will create some new data structure here. That will just messing around with some stream stuff here. Okay, so the idea is that we try to look at what do these things have in common. A box comes with a position and then some potential padding, a color. So let's start collecting information about what we want. We want a color, we want a center position, but we already know that we might be drawing lines that will we could of course implement a method where we can draw a line where we only specify the center, but we would need a vector to define that in space. So we will have a position 1, which will typically be our center, and then a position 2 that will be potentially our endpoint for a line segment. Otherwise, it will be empty. Then we will, of course, need something called a type, which will be a point, a line, or a polygon. And maybe that needs to be specified like a box, a sphere, because those are the shapes that we support right now, or at least plan on supporting. A sphere needs a radius. Since this will be a 3-component vector at least, we could use the same data structure to store the radius just in the x component, for instance, which would mean that we would need one less special case slash x equals radius. Okay, so for a point, we don't need this. We could potentially use this field here to set the kind of the size of the point. Let me see, do we actually pass on? No, we don't. It's hard-coded right now into the shader program. Let's see, point billboards. We simply pass on the position, and then in the geometry shader, we specify the sizes here. So, yeah, I guess you could change that in the future, and therefore maybe a point would like some kind of size information alongside its center position. Anyway, we define that for a line, this component here, and we will of course do some type specifications here. So for a line, this will be the endpoint in space. For a sphere, the X component will hold the radius. For a box, we will hold the half widths. And then if we expand this as a vec4, we will only be assigning one more floating point for this, and then the W component could be equal to the padding. And then we need a vec4 here. And basically, if we specify this, maybe we could even do for the sphere a bit of maybe padding if we wanted to do extra padding for some weird reason. Right now we don't have a use case. Anyway, so this could be basically the data structure that we pass into our debugging pipeline, that no matter what kind of debugging primitive that we want to do, whether it's a point, line, or a box or a sphere, we need to supply these information, and we know from this table here how the data is packed into the struct. So let's see, we build boxes from the position, the color, and the padding, and we of course build the indices from the computations of where the box is located. We could do a subdivision of simply an ABB and an OBB, because the algorithm needed to kind of calculate well, the problem is that we won't have the rotation for the OBB. We could also link to the object transform, which will always be possible to use for transforming the vertices. We could do that. We could do that. Right now, yeah, so the OBB case kind of is a challenge in terms of how to plan this out, because we could reference the transforms themselves. And we would only use them to rotate the OBBs. Let's see, for instance, if we add a debug visual, we do pass in the axis right now. Sphere, ABB, OBB, half width, axis. Yeah, we do have a method that so we could do axis computations. We could do axis computations. Well, I mean, this method here for the OBB stuff already does some sort of alignment. Yeah. So in order to be able to handle an OBB, yeah, we would need to assign the axis. In general, most things would be let's see, do we store them somewhere else so that we can just reference them? Down in bounding spheres. Do we do? Oh, that's temporary stuff. This is also pretty janky, I think. Let's see. So we do the half widths, and then we access the axis of the bounding volumes. So they're actually stored on the OBB itself. And they are updated. So we don't need to. Yeah, I realized. I mentioned that I was sad to see the number 69 go, but also happy to have reached the number 70. Okay, I think I have a plan for that. So we will simply store a pointer to the axis. This means that we won't be applying too much overhead since most of these fields will be relevant for our debugging visual. Mr. Yes, how is your project going? Or aren't you working on it right now, or? Okay. Let's devise this. Debug primitive. We also need a enum. Maybe we can do it on the. Can you do definitions on the actual struct itself? Maybe you can. So if I do another one test here, I could do a debug primitive type. Okay. Point line ABB OBB. Yeah. And do a float 3 and a float 4, and then we could do float 4, 3. Yeah, let's do. And that will be a pointer. And then float 4. And we will pre-initialize all these as 0. Well, and set this to a null pointer. And set this to a type line. And let's store this comment in here so that we can find it. Great stuff, great stuff. Okay. So our renderer will take submissions of lists of debug primitives. Objects. And we actually don't need to pass in anything else because our information here will be sufficient to draw whatever primitive we need. Our buffers here will simply get initialized with some preset state. Global settings, rendering, define. Max debug buffer size. And let's do maybe 100 points for now. And this is misleading, should be render targets in swap train. We won't change this for now, but anyway. Let's do a const on sign int equal to, well, allocation size. Let's see. Wait a minute. Whoops. That is why it's not working. Okay. And we of course want to create these buffers here. Let's see. And let's do like this, and let's disable this for now. And let's do the allocation size here. Okay. So that's basically our allocation. We can always change the allocation size. After we're done initializing our application, we want to tell the renderer to, maybe it should be since it's a resource creation thing, just to be explicit, that we have a macro-defined limiter, and this function is possible to change in terms of buffer size. We could also move this outside because it's probably debug only mode. Temporary stuff. Okay, so hopefully everything works. Everything compiles at least. And yeah, let's rename these. All right, good stuff. Let's see. Let's just test out NVIDIA Insight. It probably won't work, but I do miss the whole thing working. Well, nope. Some kind of weird bug. Anyway, we will use our new ally, render doc, and we will load our application here, and we will, of course, reference all resources. We will check debug primitive, index buffer, and vertex buffer. And they're just empty. Great stuff. So we create our resources as expected. Great stuff. That was pretty easy. So now we have a buffer to work with. Now we need to kind of migrate all of this stuff here into our submit function. Yeah, so we need to create this method here, and then create a buffer of debug draw calls. Debug draw, excuse me. And we will start, I'm sorry, populating that list. We could do separate lists. Maybe we want this part of the algorithm to be a organizing step. We could just process every object though. I think in terms of speed, we would prefer not to have if statements inside our stuff. So if the layout of this buffer slash vector here also, these should actually be const. Yeah. We should use const for this. Yeah, we should. Let's do it here so I remember that we need to do const. Maybe I do it just already, since it's better practice. We do not output anything from this method anyway. So actually this is also supposed to be const because we only copy data here. We change up data here. Yeah, I should be better at using const. Some more here. Let me just see. Right here. I'm sorry. There we go. Everything should still compile. We live up to our promise of doing only no changes, no mutations. It's better for the compiler and good general practice in, yeah, good general practice. Since C++ doesn't come with the const keyword for every variable. Anyway, that's a detour. So yeah, the problem with a if series of if statements inside our method here means that we might lose out on branchless computation, since we actually want to do computations on some objects. we should probably do some lists. So in terms of our primitive types here, the point and the line doesn't need to take any computation, so we can pass that, but the AABB and the OBB and the sphere will actually be done in computations that we want to kind of like performance optimized towards, even though it's debugging primitives and we don't really need to be performance critical. This is a nice way of implementing sort of a data-oriented design, which allows us to do well, the general principle is to sort the data, then do transformations on that data and collect the data in the end. So we will write methods for that. So we will simply try to organize our data here. If the object type equals point, we do something. Else if maybe we want to do a switch, since I think it's faster. I'm not sure, but let's do the first cases here. Case the debug primitive type is a point. We do something about that. Let me see just a second. Just a second. I was just looking at some stream stuff. Sorry about that. We do a line check here. Although we do get in a pickle here. No, let's sort the well. I mean, this const here means that I can't just move these things out of our list. Maybe we don't want to promise to not do anything because these are happily discarded afterwards because yeah, the system is not going to need them. It will do some kind of pre-computation or maybe just submission of We could also simply just do some pre-sorting because when we compile this, we will know which kind of object we have. So we actually don't need if statements. Okay. And we don't need to move anything. We don't need to do anything. We just need to make sure that the data is passed in an organized way when we submit our data. So we will change this into a vector of vectors. And we will specify vector index 0 equals points, vector index 1 equals lines, 2 equals ABBs, 3 equals OBBs, and 4 equals spheres. Thereby we don't need to kind of like sort the data afterwards. We simply create the data in order, which will be fairly easy since we will use the bounding volumes for a lot of this stuff. We will use contact points for a lot of this stuff. We will do raycasts for a lot of this stuff. Yeah, I think this will be an okay way of doing things. Maybe we will run into trouble with organizing our data and doing proper work submission, but this will at least allow us to do any pre-ordering of the data outside the renderer. We really want these submit steps to be without as many if statements or branches as possible. It's fine to have the if and branches on a higher level, since you could imagine the data pipeline being something like simply do higher order logic, determine what needs to be drawn to where and how things are supposed to be drawn. And then when you pass to lower level pipelines, you kind of just want the data stream to be like copy, process, copy, process, copy, process. Yeah, and branches kind of like screw the CPU in terms of it tries to do so-called branch prediction, meaning that it tries to figure out which branch to enter beforehand, and it has to do some cycles to correct if it wasn't in the correct branch. or rather the branch turned out to not be what it predicted. So yeah, we kind of want to minimize that happening, at least in parts of the code where we simply just want data to flow. And we want data to flow when we do computations and copying of data, submission of work. Okay, let's just copy this comment so I can always find it here. Submitting submission of debug draw calls. Yeah, I don't think we actually need this in here. Let's see, submit. Yeah, it now is part of IntelliSense. Okay. So the first series of vectors. Let's do points inside objects index 0 and do some processing of that. We could also do whatever we do during our update step here. Let's see. I'm really looking forward to collapsing, or rather getting rid of a lot of these functions, because they take up a lot of space and really don't do anything. Okay, so it happens during the render step or what? For yeah, we actually clear the dynamic draw calls there. I think you can do it up here alongside the, since you simply record them, yeah. And we do not get any errors in terms of, no DirectX errors. Great stuff. Yeah, so that makes more sense. So we should probably not clear it here, but we do have a vector that is our debug draw calls. And we need to handle that right now. Let's close this. Hello, welcome. And we want our points here. Let's see. Add visual. Wait a minute. Our point pipeline is actually different. So we need a specific method for using that. Oh, that's hard, man. Have you tried downloading for example, NVIDIA Insight and try debugging your information on the GPU, or perhaps the program RenderDoc if you prefer that, because you can see how the pipeline state and everything is set up. Otherwise, check out the dude chili tomato noodle, not DirectX12, this guy here. He does a tutorial series on doing DirectX11. So we would maybe just do this. Maybe we don't mind. And I just realized we don't need the type specifier anymore, because we already know what we submit. We already know what we submit. So we actually don't need that anymore. I'm pretty sure this is the same as, yeah, my vertex line. It's exactly the same. And we want the position to be our point. Is it the same? Is it a float? Yeah, it's a float. Position 1, and then simply the color. There we go. So this now gets collapsed into our pipeline, this whole function. Which is great. We immediately got that collapsed. Let's see, do we actually do any point buffers? Yeah, that's fine. We could actually collapse this into to one function. Maybe we should do that. And let's see. const unsigned int amount of points equal to 16, then debug vertices vertex allocations. Let's change that. And we do like that instead. Let me show you like this. So this means that whenever this gets compiled with the engine, it chooses to export. And if it's compiled or accessed outside the application in the game project. Yeah, but remember to set your preprocess statements here. In your DLL, you want this. And in your other project, you don't want anything. Okay. So now we can delete this. Delete this. And simply move this. And everything will still work, I think. Yeah. And we kind of like need to check whether we did any debugging visuals. Well, we had disabled that. Let's see. Let's just add it again and see that everything works. They work. The contact points get drawn. Okay. Let me see if this is allowed. Gfloat free position gfloat for color, and let's do a vector of temp packets, temp data, point data, temp point data. Does this actually compile or does it complain? No, I'm allowed to do in scope definitions. Okay. No. I feel the same as you. I'm not building for Linux or Mac OS right now. If I wanted to in the future, I think it could be done. So yeah, no worries, man. Don't worry about your English. It's perfectly fine. Okay, let's see if we do something like temp point data in place back with the position contact point and then the color here. Well, maybe we don't want that actually. Maybe we, maybe this is wasteful. Debug, primitive. Yeah, I think that is wasteful. So the first, let's see, 0 dot. Let's see, maybe something like this. Temp point data. Huh, it doesn't like it when I do that. Well, perhaps it would want all of the information. That's a float 4, float 4. Maybe then a null pointer. Nope, doesn't like that. Oh well. Maybe if I do like this. Yeah, well, everything is fine and dandy then. Great stuff. Everything compiles. Then we can do a vector of vectors of debug primitive data. Total debug. And we want total debug to have our temp point data moved into the first slot. And then we will, yeah, this should work. And right now we don't draw anything. Let's do, hello man. Let's try submitting the debug information. And we successfully translated to our new system. Great stuff. Let's move this outside of the scope and let's move. I have a, no problem. Thanks for tuning in and good luck on your project. Remember, I'll do a tutorial episode on DirectX12 tomorrow. I'm running on a 7700 and a GTX or RTX 2060, so the GPU is kind of slow. But for now, since I'm not messing around with ray tracing or a lot of advanced techniques, I think it's sufficient. It doesn't run great. Okay, let's see. let's do it down here. 10-point data is not defined. Let's see, did I not move it outside the, oh, the physics scope is even further outside. So let's do this. Great stuff. So this is our new system. We can, yeah, let's just turn on every rendering aspect that we can. Okay, so now we have our point handling. Why do you think it runs like garbage? Oh, okay. Oh, okay. And it doesn't relate to the way that the CPU is running, or a disk issue, or a RAM issue or some kind. Okay. All right. Let's do some ray processing here. Yeah, and I suspect that it's still a fairly new game in terms of performance optimizations for different hardware. So maybe they have trouble on specific platforms. What CPU do you run? Let's grab this since I will be needing that to plan out our parsing of the data here. Oh my God. Well, shouldn't be a CPU or GPU issue at all. That's really weird that you get lag spikes. It's probably something related to the way that the game is optimized. Because with that hardware, you shouldn't get any lag spikes. Oh, okay. Well, are you sure then it's yeah, okay, maybe you're right. Okay. Hmm. That sounds weird. Did you think about, well, maybe some parts of the GPU is faulty? Huh. Weird. Yeah. Well, that does sound weird. But yeah, maybe it's a driver issue. Have you updated your drivers lately? Since DirectX 11 uses the driver a lot more. Yeah. Okay. Let's do the same thing as down below. Position 1 and no. Well, seems like you did all the right things then. Actually, our math stuff here, do we allow to grab where did I define it or declare it? Actually, it's both. G float 4. There we go. We could truncate the last component. Well, we will just do like this. X, okay, R, maybe copy with the comma, G, B, there we go. And RGB, RGB, A. Well, that seems correct. How's it going with your application? And we do the same thing here. Oh, all right. I should also do a break soon. Okay, so we of course pass our line here. Right now we want to register draw calls. Yeah, well that sounds nice. Did you get to handle the faces yet, or was that ahead of you? Okay, so now we want to register draw calls, which means that we also need to manage how our indices and vertices are placed in our buffer, which we update each frame. So therefore we need something like a current vertex Nice. Current index. Did you process the faces? Because when you process the faces, you actually create new vertices. There are more unique vertices than the vertex list. I don't know if you recall, but that's what I've showed you in the OBJ parser. Oh, okay. But yeah, great. Well, yeah, you can start uploading the basic primitive then. It doesn't care if you have enough vertices. That's only for texturing and normal mapping that it really matters. Yeah, yeah, that sounds great. It'll be fun to get something up on the screen. Screen, not screen. Yeah, exactly. Okay, so now we need to create a debug or render call or draw call. Yeah, you just need to swap the model vertices for those that you hard coded. Let's do draw call here. And register some stuff. Let's see. We would want to add to the current index afterwards with a factor of 2, and the same thing for the current vertex. And we basically, yeah, of course, man, good luck. So we register our draw call here. Amount of vertices will be 2. Draw call amount of indices will be 2. And then yeah, it's always hard to plan ahead. You have to kind of like tinker with it. So I'm also really slow at that. I've been working on refactoring all of this stuff all day, and I'm not done yet. So it takes a bit of planning to kind of decide how to create your program structure, and also you have to take into consideration the data flow. Well, I did that a lot. Let's see. This is yeah. That's great practice. Once you get more comfortable that most of your things are probably mostly right, you will end up where uh, you will be doing it less. Yeah. I think I do less unit testing now than I used to do, but I still do it, especially if I do something that I haven't done before. Let's do a more clear name here so that we don't get confused. Whoops. In the future. Okay, so whenever we register a line, we simply increase the offset and we submit our draw call here. We also need to our draw call here. We of course also need to store the information in our buffer. And where did I put the buffer names? We don't need this. All right, they're up here. Maybe just copy this and undo that. Okay. We could do one big copy. That's an optimization. That's an optimization. Actually, we could just use the registered draw call here. Let's try doing something a bit fancy. We could collect a large list of vertices outside the scope and simply append that for each primitive. And then in the end, since we already know the offset stuff in terms of looking into the buffer, we can simply just copy it. We don't even need this information because it is already stored. All right. I think we will do that. So we will also create a temporary storage of sorts. Vertex line, which we will append to dataset. And we will simply take our dataset and our pushback, in place back, and move the points 1 and points 2. Well, we would also have to write the unsigned int dataset vertex, dataset index, indices. Let's do it singular. And we do the since this is just a basic integer, though there's no need to move it. And we do like this. Okay. So this will store our data, and then when we're done, we will know how many vertices and indices we have in our buffer here. Actually, we don't need even those offsets. We can just simply check how many things do we need to copy to the buffer. So let's end our function call with that. Let's see. We will do this outside, done processing, submit data, and we simply do something like and we of course need our polygon vertex buffer and polygon index buffer, and we don't need to offset anything here. We simply need the data set for our vertices, which will actually just take a void pointer to the underlying data, and we will need to know how many to copy. This creates one big call to our CPU here. Actually, I don't need this either. And we simply submit everything that is needed to be submitted after processing. And let's do this. The only performance optimization we could do would be reserve space in our buffers here. Let's move this because we want to move this down here because we're gonna work on the AABBs. Let's try testing out submitting some stuff to our pipeline here. Let's see. Okay, let's disable this old draw call here because we don't want that anymore. And actually, we don't want this either. We want. Well, I should have copied before I commented it out. But anyway, let's do. Let's move this. Move this. Maybe this one needs to be deleted because I don't do that anymore. Let's move this. The code is somewhere else. Anyway, let's close these. We won't be using them right now. Let's see our buffer names. Oh, I could have looked them up inside the header file instead. Okay, here we are. There we go. This hopefully compiles. It won't be drawing anything right now, but or will it? No, no, it shouldn't be because we're not submitting anything. Okay, we do have an error. Wait a minute. Wait a minute. I'm pretty sure. Well, that's peculiar. Because why does it do that? It shouldn't. Let's see our object data set here. Well, it only contains one element. Did we? Yeah, okay. Okay. I know how to solve this. I think we will always create empty vectors. So this will always have a for. There we go. There we go. It can't, of course, iterate over something that doesn't exist, and we don't want to check if it exists because the if statements are not nice as we know it. Anyway, should we try submitting some rays to our frame buffer here, or rather our application here? So another testing area. We will do a vector of debug primitives, test lines, and we will do a line here, line. The position will be, maybe we just wanted to go through, start from the origin. Hello, welcome. Have you been busy? And our line layout was, yeah. Let's do it alongside the z-axis, maybe in a downward going motion, -5, and then the last point here is going to be 0. And the color is going to be a great old yellow. So we do a full red, a full green, and 0 blue. Sure, I have a Discord in the channel link. Yeah, feel free to join. I haven't really set up a text channel for it. Let me just do it. Code debugging. Yeah, I've created that. Can't promise I'll look into it immediately, but I'll definitely give it a quick glance, no matter what. Okay, this is our first line. Let's do another line here. Which will go in the C direction, or rather X direction instead. And it will be a different color. Okay. So, all right, great stuff. And then we add our vector here. Okay, let's do it inside this scope here. Whoops. There we go. No, I don't think so. I can see you on the channel now. Welcome to the channel. All right, let's try testing this out. Well, so far nothing happens. Let's see. Let's see. Okay. So if we step into this area of the program, we actually skip this. Hello, welcome. Wait a minute, wait a minute, wait a minute. It's because this is no longer needed. Whoops, no, I'm in the wrong part of the program. It's because this is actually a bug, because this is supposed to be swapped. Is it just a mesh? Maybe. Let's see. I, of course, did this wrong. After I changed the whole thing to avoid debug, I introduced another bug instead. Let's remove that debug step right now. Yeah, there are lines go. Great stuff. Yeah, I think it's because I'm doing several things on the CPU as well. It might even do updating or whatever. Let's do a release mode. Yeah, I think it's related to something else. Yeah, you can see here it relates to something else. Yeah. Let's see. Well, we could disable these calls just to make sure that we aren't provoking. No, that's definitely not it. Then it's not related to the game itself, I think. Probably isn't. It's probably doing some updates somewhere. Because I mean, this isn't possible. A possible explanation for a crash in terms of frame rate. At least it shouldn't be. Let's try disabling this. Well, okay. We do have maybe if this didn't change anything, maybe. Yeah, there definitely is some kind of bug here. Well, simply upload some data. I mean, this shouldn't be a problem. Yeah, it is each frame, but you can do when you do other function calls, it does exactly the same anyway. So but yeah, I probably introduced a bug somewhere. I probably did that. Mm, let me see the Discord thing. Uh, I'm pretty sure you're not kicked. You're in the channel, as I can see. Let me see. Well, maybe I got too optimistic. Maybe these memcopy calls. Let's see, memcopy CPU cycles. Hmm. I mean, let's try stepping into this function and seeing what's up. So it does have only 2 lines. No contact points yet. And then our uh, that's weird. That's pretty weird. It really is tanking the whole application. Do I have a memory leak somewhere? Oh, now I know. Now I know. I'm so silly. It's because I don't reset this. Um, um, because I simply start out at approximately 5,000 frames per second, and each frame I have uh, at least 2 lines that I allocate to a vector of draw calls. It will or rather, it will be 1 draw call per frame, but um, this vector has to resize every time it overflows. So therefore, we will do constant heap allocations of new memory uh, in increasingly larger chunks, and that tanks the frame rate. You're not supposed to uh, um, reallocate and increase a vector size constantly forever. So I think we need to clear the debug draw calls, and then we will be fine. Okay, we're back at a high frame rate, and that was the problem. I've been in a situation like that before. Yeah, 4 to 5,000 frames per second, maybe even between 3,500 and 5,000 in debug mode with live updating of the buffers. So it's not the mem copy. It's when you keep increasing the size of a vector infinitely. That's a bad idea. It's not a memory leak, but it's it's really a stupid thing to have in your program. I was like, I gotta remember to reset the draw calls between each frame, but yeah, I totally forgot. Let's disable this and combine it into a complete section. Mr. Yes, You should be able to. I can see you on the channel. I'm unsure what you mean by getting kicked. You're still here at the server with both your accounts. Maybe you're thinking. Let me see, view channel, send messages. Let me just make sure that the channel is properly set up. But it should be. Uh, yeah, I might do that. You can do code dumps. I think you can create a thread or something, can't you? Uh, yeah, up in the upper menu on the Discord server, you can create a thread. So you can do it. I can also do private threads if you don't want the code to be shared. It's fine by me. Let me see. Members should be able to manage read message history. Create private threads, of course. So now you should be able to. Yeah, you can. In the channel, I think you can, in the upper menu, create a private thread and invite me to that. Then I will look into the code and debug it. I think you can also attach. Yeah, I think that would be easier. And in the menu on top, you can create threads. So I haven't tried that feature, but try testing it out and see if you can post your code there. Otherwise, you might have to do file attachments, but yeah, I'll look into it. Uh, okay, great stuff. So our pipelines is still working as intended. We found the really extreme bug here, and we now have line processing, which is great. Next, we want to do something more, a bit more complicated. We want to process AABB. Yeah, sure. Go ahead. If you did, I'm unsure whether you could, but how it would affect your result, I'm unsure of, because how do you process the depth of your UI, and how do you compare it to an object? I'm unsure which component in terms of the pixel shader or the rasterizer that you need to manipulate in terms of getting the appropriate depth. But yeah, you could. You could store some specific index inside your UI vertices and process that during the vertex shader step before it gets passed along to the pixel shader. That's actually a nice idea. I haven't considered that. Yeah, well, you can also set up different blending modes, and you can set up pixel discarding and so forth. So there's a lot of ways that you can make sure that a UI is always drawn on top. Generally, the easiest way is just to clear the C buffer after you're done with every other draw call. And then before you draw your UI, you clear it, and then everything is guaranteed to be drawn to the screen on top of everything else. Yeah. But I think for even specific UI elements, you could even specify a sort of C value in terms of the actual vertices, and in between UI elements even determine uh, oh, okay. Well, you could do a um, draw call before clearing the C buffer, and then again after clearing the C buffer. So you could do it in different ways. You can also set up the shaded, or rather the pipeline to handle things differently. So yeah, I don't know which way is the more efficient one, but uh, I'm unsure what you mean, constant buffer. Well, we will process our AABBs here, and we arrived. Yeah, usually. When did I talk about a constant buffer? because right now I was talking about adding C. No problem. I was talking about the vertex buffers. You can pass in a uh, um, sort of like a value for the UI uh, um, the UI depth or C layering. But yeah, there are a lot of different ways of handling that stuff. Oh, okay. Yeah, yeah, yeah. Exactly. Exactly. It's fine. Yeah, I can understand that. My pronunciation is almost the same anyway, so that doesn't make it easier. Let's see. But yeah, try drawing different stuff um, before the clear. Yeah, it is. Try drawing some things before you clear the C buffer, the depth buffer, whatever we call it, and then something else after you've cleared the depth buffer. Otherwise, you have to look into different pipelines and clipping mechanisms, or even custom depth manipulation in terms of specific areas which you upload by the um, the vertex buffer. All right. Well, did I disable these old functions here? That sounds great, man. I might end up asking you how you did your rotation stuff in terms of the UI. Yeah. That sounds like a fun project. Let's see. Let's deprecate or delete this. Well, that's a great learning experience as well. Let's see, do we ever reference that function in here? No, we don't. That is great. Let's remove this for now. Okay, let's close these. We don't need them. Right now, I think everything will run by itself. We don't need that. We want a box to be calculated. Let's copy this code. Yeah, okay. Okay, so we need to remember our layout here. I used to, but I've ported a bit of the library to my own library, and some of the implementations I've generally copied, and some implementations I've done myself, and yeah. So, but I do know the library, and I always look at it for inspiration if I don't know how to implement something. It's the same thing as the DirectX DDS loader. It's basically a knockoff of Microsoft's version, even though it's a way simpler one with less functionality. But porting the code means that you usually end up understanding it a bit more than if you just use the library. So I do find it helpful. Anyway, let's see. We want to create a series of box vertices from the AABB position. We of course want the, let's see, does it expect? It expects a reference. Let's just, huh. This expects, oh, it's because it's, okay, well, we can simply specify this as const because we won't change it. That's great. We don't care. ABB position 1. Yeah, it's fine now. And then ABB color. And then we do the ABB position 2 X, or rather A, no R. Let's do a line break here for readability. Green and blue. Let's see. Too many initializer values. Radius. Am I supposed to double clamp this? Oh no. Let's see if we pass in That will it just get truncated? It might. Let's try it out. Nope. Okay. Let's copy the data. Dot position dot red. So we copy our half widths here. Let's see. Let's initialize this as that, and we pass that in, and then the padding is in the AABB position 2 alpha channel. And that should be it, right? So what did it happen now? Okay, I will do a bit of line shifting here. Maybe we do like this. Readability. There we go. So we build our boxes, potentially padded if we want to. And we build our indices. And then we simply do register our draw call here. And the amount of vertices is equal to the size of this. The amount of indices is equal to the size of this. The offsets are like specified. And we increase the offset. And lastly, we of course need to append our buffer. I think this is done. So we will do that. You have to parse the faces individually. So the first face, you have no vertices. The faces are kind of like a map that you process in terms of determining how many vertices you actually have to create unique vertices. A vertex is a combination of the vertex position in 3D space, the UV coordinates, and the normal direction. So one vertex is actually more than its position. So you need to kind of, yeah, exactly. So you use the faces to accumulate a list of final vertices that you can use in your program. And you need to check, of course, if the vertex with that unique combination already exists. But yeah, that's the way I did it. I saw someone else do it somewhat in the same way after I did my own method, and it seems like, yeah, several people find that way of doing it. Yeah. But it's a compression thing. It's far easier to just export the combination of vertices in Blender terms, and then you have to list way fewer vertices. It's like index drawing, but for parsing, it's hell. Maybe not hell, but it's a hassle. Okay, we will need to append our buffer, temporary buffers here. So we insert at the end of this buffer, and we take our box vertices here, the beginning, and or excuse me, box vertices end, and append that. Yeah. That's even more compressed, I think. But you would probably need to supply the vertices anyway, and to save memory, you would probably, yeah, I don't know, maybe you would want to do something like it, I don't know. And we, of course, append our indices. And that's it for our AABBs. Let's see, does everything compile? Everything compiles. And we can simply test our algorithm here. Yeah, I do. It is way less memory intensive, and probably more efficient too. Yeah, that's the last thing when you parse the faces and create the vertices. You also, of course, need to track whether you have uh, the correct index for each face. Try looking up discussions of how much an index buffer allows you to reduce the amount of unique vertices to draw a mesh. It's really a large amount. So yeah, it also makes the graphics card have to span a less um, a smaller portion of the vertex buffer. It's way more efficient. People wouldn't have done it for ages if it wasn't the most efficient way. But in terms of parsing files and um, doing stuff like that, it's always a hassle. Okay, let's see. We could maybe take our static game objects and just do let's just do one here. So we have our static bounding boxes. This needs to be renamed, by the way. And we take the first one. And we create a test box. Yeah. Is this stored as a G vector? It is. So we need the math. Load float. No. Store float. Store float free. And the destination test box, not text box, but test box. We simply store the position of the center, and then we know that our half widths for that box contain our next part of the information. Let's see what. Oh, okay. I haven't implemented that yet. Okay. We will do that. Store float 4. And we will do another vector where we yeah, sure. We create a method where we grab the last component here and split it out in a vector. Let's see, let me look up this intrinsic. Yeah. Of course, we need to change that, and this will be a red, green, blue, alpha. I know that feeling, man. Don't worry. Don't worry. It's just like that from time to time. I spent 3 weeks looking for a bug in the physics system. It just happens, man. Sometimes you even just forget to type the right number, or yeah, and it can take forever to track down that bug, so don't worry about it. Okay, let's try testing the system here. Of course, we need to set a color. Not text box, but test box. And let's do a red box. And we will do the alpha as 1. Wait a minute. I of course need to create a vector. Yeah, I know. It happens to everyone, at least if they do enough programming. So don't worry about it. Test box list. There we go. Okay, let's try that out. Well, right now we do not have a lot of luck. Maybe we want to do some, well, let's do another box instead of that one, because it's the floor and it's hard to debug. Let's see. Right now we do not have anything. Let's see. Well, so far nothing really is happening. Let me see. Okay. Let's see. Let's step into this function here. If we ever get to a state where that one gets called. We do not, which means that there's probably some problem somewhere in our total debug. 1, 2. So let's just ask for a debug break here, and we will check out total debug. Slot number 2 has a size of 0. Oh, I'm so stupid. I'm so stupid. We of course need to add the test box to the list, otherwise nothing will happen. Let's remove this debug break here. And we have a bounding volume rendered. Great stuff. Our dynamic pipeline is coming along smoothly. And we're still doing fine in terms of frame rate. And remember, we're not interested in top performance when the debugging mode is enabled. We will of course disable it if we ever decide to do something performance intensive. We will not need bounding volumes in case we want to do that. At least not the visual representation. So this code is so far pretty solid. We can simply start deprecating these functions here. Maybe we want to do that in the end. Yeah, this means that this function is deprecated actually. This doesn't have any utility. This never got implemented, so these two things are gone. Let's move all of these comments since they are not relevant anymore. Great stuff. We really, as you can see, the renderer will end up having very, very few methods that will handle everything, with them even being more performant because they are more efficient in the way that they do the data processing. And it's dynamically controlled, meaning that we can always switch the renderer to a dynamic mode and a debug mode where every drawn object is uploaded to the render API every frame, and therefore you can do real-time updates of everything. That is pretty great. We only need to do the OBB and the sphere calculations. Just a moment. All right. I'll try to grind on through in terms of the last debug stuff. Let's see. We could actually deprecate this. We will do that in the end. Okay, the last part here is our OBB handling. Let's do the OBB here. OBB dot, well, the layout. I need to move the layout so I can find it. So for an OBB, we want position 1. Actually, let's just copy this because I think most of it will be the same, right? OBB, position and color. Then the half width assignment. Yeah, and then the axis is the OBB axis. But what kind of format is it? It's Okay, we need to store it in a in a register. Vector access math store flow. Load float 3. Okay, and we do a series of registers. That will be our let's see. And the axis is a pointer to 3 different floats. Maybe even, let's see, our application stores bounding volume ABBs as a array of vectors. Maybe we actually want to change that. Then maybe a G vector pointer instead. We would have the benefit of skipping that. Does this not? Okay, we need to change this to const as well. There we go. And we do our stuff there. Well, that's basically just the same then. The only difference is the way that we calculate um, our actual vertices. I think this should be it. Let's see, does everything compile? Okay, let's try submitting a OBB. We will do almost the same here, except that we will change this and we will use the dynamic bounding boxes. And we want to set the test box axis pointer. Let's do this as the first one. It will point to those. Let's see, do we need any other information in terms of handling an OBB? No, I don't think so. Let's try doing that. And we suddenly have our bounding box here. The colors are a bit weird, but other than that, everything is great. Let's see. I don't know why the colors are messed up. Um, the color. How do I parse the color? Maybe I deliberately changed the thing back in the day. The color does get passed on. The color. Yeah, okay, I changed the maximum and minimum color here. Let's just deprecate that. Not deprecate. Change that. Great stuff. Great stuff. And the last part is the last part is of course our spheres, but I actually don't have a proper way of doing spheres. We need to find a method that reasonably well make a sphere-like approximation from center and radius vertices. And we need something like, not that complex, but more sphere-like than a box. So we need some kind of algorithm that just takes the center point and the radius and draws a circle approximation, or rather sphere approximation, around that. That is basically the last part. A tetrahedron, maybe. Sphere approximations. Let's look up. If anyone, well, maybe a dome like that, but that is probably computatively expensive. I'm sorry. I think I need some kind of a break, not too far out in the future. And maybe I'll even end the stream for today. I would like to get the last thing going before I end the stream though. ICO. Well, that's probably a better approximation. We could use that. Cheapest way to generate sphere approximation vertices. Uh, 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 okay. Okay. Icosahedron seems like to maybe suit our needs. Mm. Calculate vertices icosahedron. Threefold. Uh, uh, uh. Yeah, I know, I know. I'll be doing that when I'm done with the last part of the render API update. Shouldn't be too long. I just need to figure out a way of calculate the vertices of a icosahedron. Thank you. I think we did a pretty good amount of work today. Let's see. Creating an icosphere mesh in. Okay. Okay. Let's do the Andreas Kayla. Okay. Let's try accessing our utility functions here. Mm. std vector, vertex line. The next problem will be mapping the indices, but we will build icosahedron. And we will do a result here and return the result. And let's see, what does he suggest? So this is probably the radius, right? Uh, 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 let's see what this guy says. -1, 1. So let's see, 0.1. So point number 1. Okay, this is some axis. And the t is obviously the radius. Okay. Let me just move this off screen so I can look at it while I do stuff. Okay, let's do a no, I'm not sure I understand his algorithm. Uh, 12 vertices. The golden ratio. Well, radius, maybe I can specify that. Maybe I only well, mm, uh, okay. Mm, these are proofs. Doesn't matter. Mm, uh, well, Okay. Okay, I think I've got it. I think I've got it finally. Okay, let me move this. This guy explained it a bit more in detail than this guy here. Okay, so we need to calculate. Mm, mm, uh, or did he? What is a circumradius? Okay. Mm, so we need to reserve 1, 2, 3, 4, 5, 6, 7, 8. Okay. We will need to do some math to solve this. We want a const float radius, and we want a const g float 3 reference position. And that's it. Perhaps we want, we don't know. I don't know. We could maybe support padding in the future. Okay. We need to solve this. So the golden ratio is equal to 1 plus square root of 5 divided by 2.0. And the radius is actually equal to the square root of the golden ratio plus 2. So we need to solve for that. So this means that the radius squared is equal to the golden ratio plus 2. Meaning that the golden radius ratio is equal to the radius squared minus 1, I think. At least that's what it seems. Let's try that at least. Uh, um, let's try doing that then. The radius times the radius minus 1. Let's try doing that, yeah. And then maybe I'm doing this wrong. Well, we need to scale that as well. Actually, I think okay. Okay, okay, okay. Mm. Okay, let me just do a bit of okay, can I look this method up? Is it publicly available? Source code. Mm. Can I look up the source code of this? I want to see how they calculate the radius in relation to. Right. Uh, is this some kind of Python code? Maybe it seems like. Uh, yeah, so this is the phi value that we have been seeing. Welcome back, man. Yeah, I'm trying to solve the whole ICO uh, thing here, icosahedron calculation. Um, yeah, I think this dude has done it. Um, okay. Let's do something to the like of what he does. He defines a phi. Okay, he does multiple computations of the square root of 5. Um, So we only do that once for for efficiency. Let's do a ratio. He does that by taking the square root of 10.0 plus 2 times the root of 5 and divide that by 4 times phi. And then the vertex components are equal to the radius divided by the ratio times a half, and then the other thing is also the ratio times 2.0 times phi. What's up, buddy? Yeah. And we of course want to offset in terms of our center position. So we will do a vector that we will load from our position here. And we will add that to our vertex list. Let's see, vertex line. It usually holds, well, okay. Let's do a temp vex. And we set the temp vex position. And of course we need the color. Const g float for reference color. And the color is of course our color here. The first vertex position is equal to, well, we do something like load, no, store float, not for, store float 3. And we want to store it in the temp vex position. And we want to do calculations in terms of math vector add. And we want to add our center to our vertex here. Which for the first vertex will be like this, the B, and then the A. And we will, of course, we do pushback. Well, it's fine. We do pushback for the temp vex. We only need to set the color once, because we simply copy here, and then we want to combine calls like this. Let's do 1, 2. Let's remove all of this. And number 2 is the B, the positive A, and then a 0. Then the third one is the negative B, a positive A, and a 0. All right, the fourth component here. Maybe we do 0, 1, 2, 3, since it's easier to read, and this dude also does it that way, so that means I won't be messing up anything. There we go. And we will have number 4. Number 4 will be the negative B here. Excuse me. And the 5 will be the negative A. The 0. And then the B. And number 6. Let's do the 0, the negative B, and then the negative A. Number 7, the A, 0, and then negative B. Number 8 here. A, 0, B. Number 9, negative A. Or number 10 here. And hopefully the last vertex here. Let's do minus. There we go. Okay, this should be the actual vertices. At least that's what we hope. In our renderer, we will implement a sphere parser. Let's see. And we will do a sphere vertices is equal to utilities. Build icosahedron from our sphere position, and then our sphere position dot R value, and then our sphere color. And we do the same thing here. And then we do a list of indices, sphere indices, which do not have a function yet. This will be moved down here. We will do some temporary indices. We can't use this guy's algorithm because he's drawing an actual mesh. So let's just do something like pushback 0, then sphere indices, pushback 1. We will need to devise our own way of drawing this thing. I nearly called it a thing. Anyway, we do this. We do the debug render call here. And we do the sphere indices. We do like that. Great stuff. And let's test it out. It's not done yet, but we're getting close. Test sphere list. And we will update this. We will also do a test sphere. We will probably do something a bit different here, but we don't need the axis. We need the test sphere here. Okay, so our second, or rather, did we do a actual assignment of let's close some of this. In our application, dynamic bounding spheres. I think we do add one. So therefore, it's a vector. Okay, so we need this. There we go. And then we store the radius in the x part of position 2. Let's see. This is just a basic float, therefore we don't need to set it up like that. We can do something like this. The radius and then 0, 0, 0. Let's try that. I'm unsure how this will turn out, but okay. Well, we ended up in a situation where something crashed. Let's see. Yeah, there we go. Oh, wait a minute. There we go. And we do get some kind of weird weird line here. Mm. Let's just try resetting the application, swapping to the free floating camera. That is somewhat big. That is somewhat big. Let's see. How do I actually determine the bounding volume, dynamic game objects, radius is 3. If I set it to 1, what will happen? Well, the collision algorithm, of course, doesn't behave very nicely. Yeah, so there's a difference between how the let's see, did I change that position there? Let's go. So the icosahedron is kind of drawn up here. Which is obviously wrong. So this method here for, yeah, why was that? Did I do something wrong in terms of calculating this? Uh, let's set this to set 0. Ah, maybe I want to. Okay, I definitely need a break before I do any more work on this. Since I need to dive a bit into the math. I think the way that we had the center position is correct, but maybe the radius is not correct. Mm. Uh, mm, yeah, it seems well. Good, good you realized that, or rather not realized, found the bug. Okay, we do have a formula here. Is it possible to paste that? No, it does. It's not. Well, there's obviously some performance. Mm, since we need to add these things anyway. Okay. We could do this in a different way, but um, yeah. Mm, let me just do some algebra here. Off screen on paper. Since I want to manipulate this equation. Do I have a pencil somewhere? Hopefully I do. Well, I'm not sure where it went. There. Excuse me for any noise that I might make. Let's see. So this guy says that the radius divided by 2 times sine of 2 times pi divided by 5. You can substitute that. I'm sorry, I'm blabbering on. Okay, that cancels out. So it will just be the radius divided by the square root of the times square root of 5. Oh my god, the algebra here is kind of annoying since I don't really know the equations. Yeah, it's true. I'm trying to read into the math. Yeah, maybe I'll do it off stream. I'll probably end the stream for now. Do a bit of eating, then study the math for this icosahedron. Right now, it's not working as intended. The API is working fine, but I need to calculate the vertices of a icosahedron given the position of the centroid and the radius, since it's a sphere approximation. But yeah, it's been a good run. Thanks for everyone who tuned in, who subscribed and joined the channel today. Everyone who interacted, who dropped by with questions. Yeah, in general, anyone who interacted with the stream. Hopefully you found some of it helpful, inspirational, or just maybe a bit entertaining. And hopefully I'll be seeing you around. All right, take care, everyone. Bye-bye.